Now come to the session 39. So we already know in the previous sessions, uh, Newton gravity forward interpolations, backward interpolations, some problems on forward and backward. Now and the Newton interpolations formula. So we are completely finding odds to find the dy by dx and d square by dx by using Newton forward interpolations formula. See, by derivative using the Newton's already in the previous slide, the derivative of using a Newton's forward interpolations formula. Consider the Newton-Gregory forward interpolations formula. Suppose y equal to y naught plus p delta y naught plus p into p minus 1 by 2 factorial del square y naught plus p into p minus 1 p minus 2 by 3 factorial del cube y naught plus p into p minus 1 p minus 2 p minus 3 by 4 factorial del raised to 4 y naught, etc. I call this equation as 1. Also we know p can be written as x minus x naught by h, where h is the interval. I call this equation as 2. Now differentiate 1 with respect to p. So first we simplify here p into p minus 1. This we can write p square minus p divided by 2 factorial. Also p into p minus 1 p minus 2. So suddenly we get p cube minus p cube minus 3p square is 3p square plus 2p we get 2p by 3 factorial. Again, if we simplify in the p into p minus 1 p minus 2 p minus 3, we get p raised to 4 minus 6p cube plus 11p square minus 6p divided by 4 factorial. So if we simplify, then start to differentiate with respect to y. If we given 1, we start to differentiate with respect to p. So dy by dp equal to differentiate with respect to p. The first term is 0 because next p into delta y naught, we get delta y naught plus if we differentiate p square minus p divided by 2 factorial, we get 2p minus 1 divided by 2 factorial del square y naught plus again differentiate with that term, we get 3p square minus 6p by plus 2p. Sorry, minus if we differentiate, we get p into p minus 1 minus p square divided by 3 factorial, we get so 3p square minus 6p plus 2 divided by 3 factorial del cube y naught plus if we differentiate for that, we get 4p cube minus 18p square plus 22p minus 6 into del raised to 4 y naught divided by 4 factorial, etc. Again, if you differentiate 2 here with respect to x, we get dp by dx equal to 1 by h. I call this equation as 4. Now, if you find the dy by dx by using the chain rule, dy by dx equal to dy by dp divided by dp by dx. Now we go again dx by dp, so we get dy by dp into dp by dx chain rule formula. So dp by dx, now dy by dp, so dy by dp is 1 by again, so dy by dp is 1 by h. So I am substituting dp by dx. What's the dy by dp? dp by dx is 1 by h. dy by dp I am substituting delta y naught plus 2p minus 1 divided by 2 factorial del square y naught plus 3p square minus 6p plus 2 divided by 3 factorial del cube y naught plus 4p cube minus 18p square plus 22p minus 6 divided by 4 factorial plus del raised to 4 y naught, etc. So again I call this equation as 4. See, 1 by dp by dx is 1 by h, dy by dp as substituting delta y naught plus 2p minus 1 divided by 2 factorial del square y naught plus 3p square minus 6p plus 2 divided by 3 factorial del cube y naught plus etc. I call this equation as 5. The expression 5 gives the values of dy by first derivative. The expression 5, the first derivative. So dy by dx at any x which is not tabulated. The formula phi becomes the simple for tabulated the values of x, in particularly when x equal to x naught and p equal to 0. So if you replace x equal to x naught and p equal to 0, so we get dy by dx at x equal to x naught is equal to 1 by h. Put p equal to 0, we get delta y naught minus 1 by 2 del square y naught plus 1 by 3 del cube y naught minus 1 by 4 del raised to 4 y naught plus minus etc. You get that. So delta y naught minus 1 by 2 del square y naught plus 1 by 3 del cube y naught minus 1 by 4 del raised to 4 y naught plus 1 by 5 del raised to 5 y naught minus 1 by 6 del raised to 6 y naught etc. I call this equation as 1. I call this equation as 6. Now again come to the, if you want to find the second derivative, so d square y by dx square, so you take d square. Now I'm using the, again I'm using chain rule formula, dy by dp of dy by dp of dp by dx. To find the second derivative, you are using the same formula, the chain formula, d by dp of dy by dp into dp by dx. So we already know dp by dx is 1 by h. Also dp by dx, d by dp of dy by dp. So already differentiating, we know the term dy by dp. Again we start with respect to differentiate with respect to p. So 1 by h. So again I start to differentiate with respect to p. So 1 by h already know. So again 2 of. So p, if we differentiate with respect to p, is that get 1. So 2 into p. So p is 1. So we get 2 by 2 factorial del square y naught. Again plus 6p. Again we get 6p minus 6 by 3 factorial del cube y naught plus 12p square minus 36p plus 22 by 4 factorial del raised to 4 y naught plus etc. 1 by h. Again I am putting p equal to 0. We get, so d square y by dx square at x equal to x naught. Yeah, 1 by h, 1 by h. So 1 by h square. So 2 by 2 factorial. So 2 factorial is 2, get cancelled. So suddenly del square y naught. If a p is 0, so we get minus 6 by 3 factorial. So 3 factorial is 6, get cancelled, 6. So 1 by, so minus del cube y naught. Again p is 0. Again we get 22 by 4 factorial is 24. 22 by 24. Suddenly we get 11 by 12 del raised to 4 y naught etc. So del square y naught minus del cube y naught plus 11 by 12 del raised to 4 y naught minus plus alternate sign we go. This is the way to find the second derivative at x equal to x naught when p equal to 0. Now the same way we can find in another way by using the shifting operator e. So we know the formula e equal to e for hd. E is equal to e for hd. So e we know by using the forward difference 1 plus delta is equal to e for hd. Now take log on both sides. Take log on both sides. Log of 1 plus delta is equal to hd. Now hd equal to, I apply the formula log of 1 plus x formula. So we get log of x plus log of 1 plus x is same as if we replace x is delta, that's all. So x minus 1 by 2 x square 1 by 3 x cube minus 1 by 4 x raised to 4 plus 1 by 5 x raised to 5 minus 1 by 6 x raised to 6. So even term is negative, odd term is positive, 1 by 3 like that. So similar same way, if we x in place of x is delta, so we get hd equal to delta minus 1 by 2 del square plus 1 by 3 del cube minus 1 by 4 del raised to 4 plus 1 by 5 del raised to 5 minus 1 by 6 del raised to 6 etc. So replace d is small d is capital D set 1 by h. So d equal to 1 by h del minus 1 by 2 del square plus 1 by 3 del cube minus 1 by 4 del raised to 4 etc. So multiplying y naught on both sides. So delta y dy naught is equal to 1 by h delta y naught minus 1 by 2 del square y naught plus 1 by 3 del cube y naught minus 1 by 4 del raised to 4 y naught plus 1 by 5 del raised to 5 y naught etc. So this is the first derivative with respect to x at x equal to x. Suddenly we can write 1 by h of del y naught minus 1 by 2 del square y naught plus 1 by 3 del cube y naught minus 1 by 4 del raised to 4 y naught, etc. Now, to find the second derivative, by using the same way, again h square d square delta, we square that first, we get h square d square is equal to delta minus 1 by 2 del square plus 1 by 3 del cube minus 1 by 4 del raised to 4, etc. whole square. Again, d square we can write 1 by h square of d minus 1 by 2 d square plus 1 by 3 del d cube minus 1 by 4 del raised to 4, etc. square. So suddenly we get, so if we take this time, so 1 by h square d square minus d cube 11 by 12 d raised to 4 minus 5 by 6 del raised to 5, etc. This is the way to find the second derivative by using E operator. So this is the same form in the form of Lagrange's interpolation formula. See, this is the method to find dy by dx, d square y by dx. For simple example, to find dy by dx or d square by dx square, for the independent variable is given. For example, from the table, the values of below computed dy by dx and d square y by dx square at x equal to 1. See, the x table is given. So x is given. The variable, independent variable x is 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. Corresponding values of 1.1 is for x equal to 1. The corresponding values of y is 7.989. Corresponding values of 1.1 is 8.403. Corresponding values of 1.2 is 8.781. Corresponding values of 1.3 is 9.129. Corresponding values of 1.4 is 9.451. The corresponding values of 1.5 is 9.750. Corresponding values of 1.6 is 10.031. Now you want to calculate it by using this table, putting the values of x argument, the entries. See, the argument should suddenly increment 0.1. So the interval should be a 0.1. So corresponding y value should be, if x is 1, corresponding value should be 7.989. So this is, so delta is, this is the difference, 8.403 minus 7.989 is 0.414. So the difference of this term should be 8.781 minus 8.403 is 0.378. The corresponding difference between 9.129 minus 8.781 is 0.348. The corresponding difference between 9.451 minus 9.129 is 0.322. So corresponding difference between 9.750 to 9.451 is 0.299. The corresponding difference between 10.031 minus 9.750 is 0.281. See, again you take a del square y. So take this difference 0.378 minus 414 is minus 0.036. The corresponding difference between 0.348 minus 0.378 is minus 0.030. So take this difference, suddenly we get, this is the difference for second derivative, minus 0.036, 0.030, 0.026, 0.2023, 0.018. Again, if we take a third derivative, difference is minus 0.030, minus of minus we get plus sign. So suddenly the difference should be 0.006. Again, take this difference, 0.026 minus of minus plus 0.030 is 0.004. Again, take this difference, suddenly we get 4, suddenly we get 5. So this is the third derivative, we get 0.006, 0.004, 0.004, 0.005. Again take this differences, we get minus 0.002, 0.001. Again take this difference will be equal to negative of negative become positive 0.002 minus 0.001. Again take this difference minus of minus, again minus sign, so we get minus 0.003. This is the table. We get all the values of del, del square, del cube, del raised to 4, del raised to 5, del raised to 6. Now first we find first derivative. Find the dy by dx at x equal to x naught. The formula should be 1 by h of del y naught minus 1 by 2 del square y naught plus 1 by 3 del cube y naught minus 1 by 4 del raised to 4 y naught plus 1 by 5 del raised to 5 y naught minus 1 by 6 del raised to 5 y naught. Because sixth derivative needed, because there are 6 terms here appear. So see at a time. So again I'm substituting the values. So also we are taking second derivative. D square y by dx square is at x equal to x naught is 1 by h square d square y naught minus del cube y naught plus 11 by 12 del raised to 4 y naught minus 5 by 6 del raised to 5 y naught plus 137 by 180 del raised to 6 y naught. So substituting all the value in the tables, we get h equal to c. The interval should be c 1.1, 1.2. The difference should be 0.1. At initial value x naught is 1 and the delta y naught initial value, so delta y naught, so like that as substituting here delta y naught here 0.414 del square y naught, so del square y naught is 0.0036, 0.036 etc. Now substituting a suitable substitution, so 1 by h is 0.1 as substituting delta y naught first derivative minus 1 by 2 del square y naught here minus 0.036 plus 1 by 3 for del square y naught is 0.006 plus minus 1 by 4 del cube y, so substituting minus 0.002 plus 1 by 5, again this is 0.002 minus 1 by 6 minus 0.0. I'm substituting by using the scientific calculator. We get the values should be equal to 4.354. 4.354. This is the first derivative. We go for second derivative using a suitable substitutions. So is equal to d square y by dx square at x equal to 1, because here the given problems at x equal to 1, not at even the problem at x equal to, replace x equal to 1. So the way we come to that at x equal to 1 minus 1 by 2 h square, so 0.1 whole square. So del square y naught is given minus 0.036. So minus del cube y naught. So 0.006 plus 11 by 12 del raised to 4 y naught. So this is the minus 0.002 minus 5 by 6 del raised to 5. So 0.002 plus 137 by 180. So del raised to 6 y naught should be minus 0.003. So simplifying, we get minus 4.76. This is the way of finding dy by dx square and d square y by dx square. So similar way to find one more problems. So for find the dy by dx and the d square y by dx square for x equal to 1 for the following data. So x is given the interval 1, 2, 3, 4, 5, 6. The corresponding values of y is 1, 8, 27, 64, 125, 260. So here the interval should be equal interval. H is 1 and x naught initial value should be 1. The difference table is, take the tables. The x is 1, 2, 3, 4, 5, 6. The corresponding value of y is, for x is 1, for x is 1, y is 1. For x is 2, y should be 8. For x is 3, y should be 27. For x is 4, y should be 64. For x is 5, y should be 125. For x is 6, y is 260. The difference is delta y should be 8 minus 1 is 7. 27 minus 8 is 19. 64 minus 27 is 37. 125 minus 64 is 61. 216 minus 125 is 91. del square, the corresponding difference of 19 minus 7. So 12. So 37 minus 19 is 18. 61 minus 37 is 24. 91 minus 61 is 30. So I can take a del qy, the corresponding. 18 minus 12 is 6. 24 minus 18 is 6. 30 minus 24 is 6. Again I take a difference to be 0. So take a formula, Newton formula dy by dx at x equal to x naught. So take, this is the formula. So 1 by h delta y naught minus 1 by 2 del square y naught plus 1 by 3 del cube y naught minus 1 by 4 del dash 4 y naught, etc. So dy by dx at x equal to 1, certainly h is 1. So see, the interval difference is 1 by 1. So del y naught is 7 minus 1 by 2 del square y naught is 12 plus 1 by 3 del cube y naught is 6. X enough. For all other higher derivatives should be 0 limited. So 1 by 1 is 7 minus half. So 12 you get cancelled. 7 minus 6 plus 2. So suddenly we get 3. So dy by dx at x equal to 1 is 3. Observe, dy by dx at x equal to 1 is get 3. Second derivative, d square y by dx square at x equal to x naught. This is a formula 1 by h square del square y naught minus del cube y naught plus 11 by 12 del raised to 4 y naught. So substituting the values, d square y by dx square is 1 by 1, 12 minus 6 is 6. So dy by dx at x equal to 1 is 3 and d square y by dx square at x equal to 1 is 6. So this is the way you are finding derivative for given the tabulated values. So tabulated values. Similarly, we can find one more way using the in form of and higher form. So if we take find dy by dx and d square y by dx square at x equal to 51 from the following data. So x is the given table. X is 50. Corresponding value of y should be 19.96. The x is 60. Corresponding value should be 36.65. X is 70. Corresponding values of y is 58.81. X is 80. Corresponding values of y is 77.21. For x is 90. Corresponding values of y is 94.61. So we have observed the interval differences 50, 60, 70, 80, 90. So h is 10. So I take a p equal to the formula x minus x naught by h. So at x is given, at x is 51. So x naught already know initial value. So 51 minus 50 divided by 10. So suddenly we get 1 divided by 10. So 0.1 we get. So p value should be interval value should be a 0.1. At x equal to 51, p equal to 0.1. So take a table. So x equal to 50, 60, 70, 80, 90. So p should be x minus 50 divided by 10. So put x equal to here. 50 minus 50 divided by 10 is 0. Put x equal to 60. 60 minus 50 divided by 10 is 1. So again put x equal to 70. 70 minus 50 divided by 10 is 2. So 50x equal to 80. 80 minus 50 divided by 10 is 30. 30 divided by 10 is 3. So again 90. Put x equal to 90. 90 minus 50 divided by 10. So 40 divided by 10 is 4. So p we get this interval. The corresponding value should be equal to is given 19.96, 36.65, 58.81, 77.21 and 94.61. So delta y, take it this difference 36.65 minus 19.96, certainly we get that 16.69. 58.81 minus 36.65, suddenly we get 22.16. 77.21 minus 58.81, suddenly we get 18.40. 94.61 minus 77.21, suddenly we get 17.40. We come to the second del square y, the second order, 22.16 minus 16.69, we get 5.47. Again 18.40 minus 22.16, we get minus 3.76. Again 17.40 minus 18.40, suddenly we get minus 1. So again it take a difference minus 3.76 minus 5.47, we get minus 9.23. Again, minus 1, minus of minus plus 3, we get 2.76. Also, if we take this difference, delta raised to 4, we get minus 2.79, minus of minus plus, we get 9.23, we get 11.99. So, substituting dy by dx at x equal to 51 and p equal to 0.7, we get 1 by h del y naught plus 2p minus 1 by 2 factorial, because I need a value 2p by del square y naught plus 3p square minus 6p plus 2 divided by 3 factorial del cube y naught plus 4p cube minus 18p square plus 22p minus 6 divided by 4 factorial del raised to 4 y naught, etc. By using a suitable substitutions, we get 1 by h. So 1 by 1 fact 1 divided by 0.1, suddenly we get that 1 by 1. So we get 1 by 10, 16.69, 0.2 minus 1 divided by 2, 5.47 plus 3 into 0.1 whole square minus 6 into 0.1 plus 2 divided by 6 of del square y naught. If we substitute all the value, we get 1.0316. This is the way. Again, you find a second derivative. You find a second derivative that d square y by dx square at x equal to 0.1. So 1 by h square d square del square y naught plus p minus 1 del cube y naught plus 6p square minus 18p plus 11 divided by 12 of del square del raised to 4 y naught plus etc. So substituting all the values, suddenly we get 1 by 10 square. So suddenly 1 by 100. So del square y naught is 5.47 plus p is 0.1 minus 1 del cube is minus 9.23. So substituting the all in the tabulated values here for the formula, we get d square y by dx is 0.2303. This is the way you are finding dy by dx and d square by d square by using the Newton forward interpolations, and you will get tabulated values.